Okay, so this time we're going to be dealing with qualitative variables in regression. Now, the regression we're doing in this class, the standard, what we call ordinary least squares regression, relies on a numeric dependent variable, but we can have categorical independent variables. So we have some data here, and basically we're trying to predict salary based on age and whether or not you have an MBA. So let's like run this regression as per the book. Now the first thing is I complain about the analysis toolpack sometimes, but the thing is we can't actually give the qualitative categories into the Excel regression. We have to replace it with binary variables. And we can do that as follows. So if E4 equals no, then we'll give it a 0, or otherwise we'll give it a 1. And I got a bit antsy pressing enter. So just drop that down. You can see an MBA of yes in the new MBA column is a 1 and a 0 is a no. Okay, so now we have our data. So we're going to run a regression with age and MBA as independent and salary as dependent. And here we go. So in the Y, we're going to have salary. And in the X, we're going to add age and MBA. And where we're going to output it, well, let's just output it H2. We're really just not focusing on things like residuals and stuff in this regression. We're just kind of focusing on the basic output. So here we see we've got a very high R squared, and we can actually see we've got a very significant overall, i.e. we have 0. Then 21 zeros, and then 6.05. And let's just look at the age and MBA. So again, let's just think about the interpretation. So for somebody without, this is for somebody without an MBA in this row, and of age 0, then this would be their base salary. And again, it's meaningless because it's outside the range of the data. So let's go to the next coefficient, and this is the age coefficient. This is just saying for every increase of 1 in age, holding MBA constant, then salary goes up by just over $1,000. And this next value basically says if somebody has an MBA, remember we only have 2 states here, 0 and 1. So the interpretation with a qualitative variable is the 1 is basically, the coefficient is basically the increase or decrease if it's negative in the dependent variable of having a 1 over a 0. So here having an MBA over not having an MBA is worth almost an extra $15,000. Okay, so let's just kind of go through the examples given on page 311. So let's just think let's just kind of go to the examples. So we'll have age and MBA. And on 311, we have a 30-year-old and, sorry, a 30-year-old with no MBA and a 30-year-old with an MBA. And let's just put in the regression model. So it's going to be the intercept plus the age times the age coefficient plus the whether or not you have an MBA and the MBA coefficient. And let's just drop down. So 30-year-old on average with no MBA is going to get just over 32,000, and with an MBA gets around 44,000. Okay, so we're going to think a little bit more deeply. So we're going to build another model now. And for this, I'm going to need an extra column of data. And this is going to see if there's any interaction between age and MBA. So the business interpretation here, I guess, is that if you're kind of low age, then the MBA maybe doesn't help you. The MBA only helps you with experience. And the combination of experience and MBA kind of work positively together. So let's just have a look at this interaction between age and MBA. And basically, here, what we're going to do is it's the interaction variable is age and MBA just multiplied together. So we can just say C4 times D4, and then we're going to drop down. And what we have here is basically this interaction is going to be 0 with no MBA, but if there is an MBA, then it's actually going to be the age. So now let's try and build a model with both the age and the MBA and the interaction in it. So let's just try and build this new model, data analysis, regression. So our dependent variable is still B, but now we're going C3 to E3, and we're going to output it. Let's just say we output it here. So does this improve my model? Yes, it does. My R squared and my R squared adjusted are much higher. And what's interesting here is that the age coefficient is positive, but the MBA is kind of negative. But for each kind of increase of year in age, when they have an MBA, then we have this positive coefficient. So it's saying the MBA on its own isn't really, in fact, it has a negative coefficient, but the MBA combined with experience, they interact positively together. And for each extra year of experience with an MBA, you get an additional $500. So that would be my business interpretation. However, we see that when we have the interaction, the MBA is on its own is no longer significant. So even though this is negative, it's not really significant. So let's just try and build a model with intercept age and just kind of the combination of age and MBA. The kind of the interaction. So let's go back again. Now this time we're going to have to remove MBA. So what am I going to do? Okay, I'm going to cut. And then I'm going to insert cut cells. And so I was worried it was going to lose the references, but it's obviously pretty clever. So we still have the age, and then we have the interaction, the age times MBA. So let's just kind of do another model. So this time we don't want the MBA on its own. We just want the salary and the independent variables, the age and the interaction with the MBA. Okay, so now I want to actually move down a little bit further for another model. Let's just move down to I-48. And you see here that the R squared goes down a little bit, but the 9767, 97670, 97672, the adjusted R squared actually increases a little bit in this model, saying, hey, having MBA on its own was really not worth it. So this model's telling you for each additional year of age, you get an average an extra just under $1,000. But if you have each additional year of age, if you have an MBA, you get an additional $400 beyond that additional $980 $84. So let's kind of redo my little example here. So age and MBA, and let's just write in salary. So we'll do the same here, and we have salary here. So this time, and then what we'd have to actually do is we'd have to have an age times MBA column. So this is going to be equals, and drop down. And we're only actually going to, when we calculate the salary, use age and MBA. So this, we're going to have equals baseline salary plus age times this plus age times MBA times the age times MBA coefficient, and we drop down. Okay, something went wrong there. So we've got age plus I69 times J65 plus, oh, I know what I forgot to do is I forgot to do my dollars. Okay, and then drop down. So 32 and 45,000. Just make sure I didn't forget to do the dollars on the other one. Yeah, so J18. Let's just correct that. So J, never forget your dollars. And let's just see how it changes this salary. Yeah. So I mean, I didn't find the error originally because the salaries were so close in that, but we've now done it properly with the dollars, and those are our estimates of salary using this, the first model, the basic model without interaction. And so it's just the intercept plus age times the age coefficient and MBA times the MBA coefficient. And look, when we drop down, again, but with the second row, and then we do the same for our interaction model. So here it's intercept plus age times age times MBA times age times MBA, and intercept plus age times age plus age times MBA times age times MBA coefficient. Okay, and I guess there's a lesson there in always just checking 100% and making sure if you're kind of dropping something down, you want to make it the same, always remember to put your dollars on.